Let's explain why stiffness often matters more than strength in structural engineering in a very simple way. Here are two beams, same material, same strength, and the same load, but one is deeper. Many people assume strength is what controls how a beam behaves, but in many situations, it's actually stiffness that makes the bigger difference. Even under the same load, the deeper beam deflects much less. Strength didn't change, stiffness did. And stiffness is what controls deflection and how a structure feels. People don't walk into a building and say, I wonder what the moment capacity of this beam is. They only notice whether the floor feels solid or bouncy. That's stiffness. Strength depends on material capacity and the size of the section. Things like yield strength of steel, compressive strength of concrete, and how much cross-section area you actually have. Stiffness depends on both the material and the geometry. Material stiffness is captured by E, the modulus of elasticity. Geometry is captured by I, the moment of inertia. And deflection is inversely proportional to E times I. In this example, the material is the same, so E stays constant. The only thing changing is I. The deeper beam has a much larger moment of inertia, which makes it much stiffer even though the strength hasn't changed. Stiffness is not always more important than strength. It depends entirely on the situation. In some designs, especially floors, long spans, cantilevers, or anything with vibration and deflection concerns, stiffness is what governs. That's what controls comfort, cracking, and serviceability. But in many other cases, strength is what governs, especially for columns, shear critical members, heavily loaded beams, or anything carrying large concentrated load or compression. What designers really do is check both. Sometimes stiffness controls, sometimes strength controls, and sometimes they're both critical. In our simple example, we kept the load small and the material constant, so the deeper beam feels stiffer even though both members still have the same ultimate strength. So strength makes sure a member doesn't break. Stiffness makes sure it doesn't move too much. And most of the time, movement, not breaking, is what matters. If you want more simple explanations like this, subscribe to the channel. This is Reza from SIPCO.